I'm Jaq. I'm from the UK MECC team. Today I'll be walking you through the February 2025 MECC Varsity case, Whodunnit. This case will show you how to use code and CHAR functions, as well as give us a bit of a chance to set up some simple lambdas for those of you stretching those lambda muscles. Let's jump right in. Level 1 introduces the CHAR and code functions, which allow you to switch between a character and its corresponding code and back again. In the example, you can see that we're being asked to switch either from a character to the code or from the code to the character. This will use both sets of functions. Here is how the function works. For the character M, we want to derive the code, which gives us the number 77. And for the code 84, we want to derive the character, which gives us the letter T. This corresponds to what we're seeing in the answer sheet. What we can do here to solve, because we have both codes and characters, instead of using an if statement with is number, for example, to determine whether it's a code or a character, I'm going to use an if error statement to produce a slightly more elegant version of the solution. This works because if you run the character function on something that's already a character, it's going to generate an error. Let's give it a go. And that gives us the solution. Let's copy this down, see how we do. And there's a full set of solutions that works for both the character and the code, switching over. Level 2 extends the functions we've just used. The character and code functions have a limit of only 255 values. Let me show you. Let's take a sequence of 260 values and take the character of each of these values. Obviously, some values don't necessarily represent themselves very well in Excel, but as you can see, we have our numeric values, our characters, letters of the alphabet, as well as a number of other characters. But once we hit the mark of 255, which is an 8-bit minus 1, we actually run out of spaces. So what Excel did here was to introduce two new functions, UNICODE and UNICHAR, which extended this limit to over 1 million possible characters. Here we can use UNICODE on one of the characters that aren't in that list we saw earlier. And we can use UNICHAR on a number that's much higher than 255. We're going to use exactly the same formula as we used in level 1. Except we're going to be switching out CHAR to UNICHAR and code to UNICODE. And there's our level 2 solution. Level 3 shows us a great use of the UNICHAR and UNICODE functions when it comes to using something like a cipher shift. We're given an initial letter and we're asked to shift it along the alphabet by a certain amount. To solve this, we convert the letter to a code, add on the amount we wish to shift it by, and convert that back to a character. There's your solution. Let's copy this one down. That gives us our solution. Now, as you can imagine, if you shift before the letter A or after the letter Z, you're not going to get a valid letter by just using the formula from level 3. Let's see. Not a letter. What we're expecting here is C going back should be B, A, and then Z. We need to go a step further here. Let's walk through this. First, we get the code. The first letter of the alphabet, A, let's put this in a cell here, has the Unicode 65. So we're going to reduce the code that we have down so that we have a list from 1 to 26 of the values from A to Z. This means subtracting 65 minus 1 from the Unicode that we have now to get the position in the alphabet of the current string. Now we should have letters from 1 to 26 for all of the input strings A to Z. Let's add the shift that we currently have and see where that puts us. Zero. This is not one of the numbers 1 to 26. This is where we start to use a mod function to get the modulus or the remainder of this new number after dividing by 26. Now the interesting thing about the mod function is what it will do for a loop like 26 is when you take the mod of any of these numbers by 26, it will return that number except for 26. Here we get the number 0. So we need to do a small adjustment here. So instead what we'll do is we will take the mod of the starting number minus 1 with 26, and then we're going to add the 1 back into it. This gives us the numbers 1 to 26, and 26 returned for this is fantastic. And now this is an excellent place where you can start creating a lambda. This mod adjustment that we're using for letters of the alphabet can be used on anything else that you want to loop around in sets, in any of these competitions, or just in Excel in general. So a nice way of doing this is you know that you're going to have to mod minus 1 plus 1 at the end to not get that 0 value. So let's just create a small lambda. First input is going to be your number. Your second input is your divisor. What we're going to return is the mod of your num minus 1 divided by your divisor, and then you're going to add 1 back in. And as an example here, we're going to save it with that number and the number 26 as our divisor. As you can see, it's producing the correct value. To save this as a lambda, we can now take the lambda formula equals lambda up until just before we put the arguments in. Copy that, go into your name manager, and just create a new named range. I'm going to call mine X-MOD. And in the refers to, we paste the formula that we've just created. We now have new lambda. Returning to the case here, instead of using mod with 26, let's change this to use our new lambda X-MOD. Alternatively, you can still use the mod with the minus 1 plus 1. After you have applied your X-MOD, add the 64 back in. This brings us back up to the character codes that we're looking at, and finally you can do a UNICHAR on the new code. This gives us the solution Z. So let's summarize this all in one formula. Start with the UNICODE of the letter. I'm going to subtract 64. I'm going to hard code it this time. We know what it is. We don't need to point it at a hard coded number there. I'm going to subtract that from 64. This gives us the letter in the alphabet. Now we're going to apply the shift that we've been asked to include. This gives us a new letter. this time it would actually work, but we're going to apply the X-MOD function to make sure that it's within the range from 1 to 26 with the number 26. We're going to add 64 back on to bring it back up to a usable code, and then we're going to use UNICHAR around that code to give us the final solution. Fill down, and those are your answers. Level 5 is extending this knowledge a little bit more. Let's take the functions that we used in the last session and copy this down. See if this works. Now, as you can see, for level 5, we're given an entire word, not a single letter. But our UNICODE function works only on the first character of the word. So what we actually need to be doing is set up a way that this word is listed as an array formula. So let's begin with that. I'm going to start by just linking the word over here and making sure that I update all my formula so that they're pulling into the right spot. Now this is where it starts to get interesting. That obviously is only pulling in the first character. We want these characters split out. So first step, we're going to get the length of the encrypted word that we're starting. It's 5 letters long. As you can see, the examples that we're given here can be any length. We're then going to generate a sequence. Sequence is a great function, incredibly useful in so many areas. In this case, we're going to use it to pick up each of the characters in this word. We're going to use this with a mid function where we point at our encrypted word. We pick up the characters starting from each of those numbers 1, 2, 3, 4, 5. And we only want to pick up one character length. As you can see, this now gives us C, W, H, V, W as separate characters. Just going to put this on the right so that it doesn't look like it's blending into the rest. Now we can extend our UNICODE function to look at the array formula. As you can see, that naturally extends really nicely. Again, another array lookup we can use there. And then we can once again add the shift to our array, apply our mod function to an array, adding that hash. And finally, convert that value from 1 to 26 back to the range of codes that we need for the letters A to Z. And then UNICHAR can be applied to the array of these numbers to get our new result, which is ZTEST. And finally, we're going to close it out by using a CONCAT function on the array. And that gives us our solution. So obviously, it's going to be a lot easier if we can do the same thing we did in the last function and convert all of these into a single cell formula solution. This function that we've set up to extract the characters of a word is one that I currently hold in a Lambda in my personal Lambda collection. This is another great, incredibly useful function that you can be setting up for your own Lambda library or stealing from someone's Lambda library online. But let's get started. When you're building a formula as a single cell formula, we're going to do it in exactly the same way that we've done it here, from the inside out. So these are our steps: extract characters, get code, code to 1 to 26, shift code, mod code, back to usable UNICODE. Get characters and CONCAT. So there's a nice reminder of the steps that we're doing. I'm going to replicate those steps from the inside of the formula, building outwards. For ease of use, I'm going to use a let function, simply so that we can build this up as a step-by-step without necessarily creating a monster function. It allows us to see a lot easier what we're trying to do. So first we're going to let the encrypted word, enc word, be this, and we're going to let the shift be that. We're going to take letter L to represent length and get the length of the encoded word, encrypted word. S to get a sequence. And then the encrypted array we will do as mid of the encrypted word, the sequence for one space, and that should give us the encrypted array. I'm just going to stop there. You can look at the first step. That has replicated this step as a let statement. I have an amazing feature in that I use robot. Excel Labs is also incredibly useful for this if you like to have things looking a little bit neater, which in a competition environment doesn't really count. But in this case, you can format your function. Format formulas. And that makes that a little bit neater. When you look at it in Excel Labs, it produces these so that they're all on individual lines and it makes sense what you're doing. For the rest of this, I'm going to complete editing it in Excel Labs because it's a lot easier to look at that way. So next step, we're going to get the start code. And I'm going to set the start code as UNICODE of the array. In the next line, we're going to shift that code down to 26 by subtracting it, by subtracting 64 from the number. So I'm going to call that alpha code, a start code for alphabet, and that's just going to be start code minus 64. The next line, we're going to add the shift. So shifted start shift code is going to be a start code plus shift. The mod of this code, I'm going to just again call it mod code, and that's going to be X-MOD because I now have that function. You can obviously use the same mod with the -1 plus 1, and we're going to use the shift code and the number 26. And then we're going to go back to the end code, which is going to be the mod code plus 64. Finally, this gives us our list of characters by, let's go as encoded array. It's not encrypted anymore. We'll just call it word array. We get UNICHAR of the end codes. And finally, we're going to return a CONCAT function of word array. Now, that gives us the word index. As you can see there, that entire function is each of these steps that we've built up along the way. Let's copy this down, see how we've done. And that's the end of question 5. Level 6 is marked as a hard level and does exactly the same thing as level 5 does, except as you can see, we're now using shifts that are much larger. So we're going back 99 steps, which is multiple laps around the alphabet. Thankfully, because of the way that we've used a mod function in the previous level, we should be able to simply copy our function and use it again. Let's have a look at the example. As you can see, we've extracted the characters, it gets the code, converts that to a 1 to 26. It then subtracts 99, which is an incredibly far into the negative number. But because we're using a mod function, the mod function magically takes it to the position in the loop of 1 to 26 that we need it to be in. Let's get this formatting a little bit better, shall we? We can convert that back to Unicode, get the characters and concatenate it, and we get the correct solution. If you'd been doing the mod step that we created in the previous in a more manual way, for example saying if this number is less than 1, then subtract this from the upper end of the letter Z. If it's greater than 90, which is the character for the letter Z, then subtract 90 from it and add it onto the letter A. Then we would have to rework this entire function and set it up in the way that we've just set it up using a mod. So we can take this function that we've written as a nice let function, stick this down in level 6, and as you can see, we already have all the solutions for level 6. Now level 7 goes one step further. As you can see, we're just doing a step at a time, making things harder and harder and harder as we go. What we have here is an entire string, which we can deal with now that we've done words, but we don't know how much it's shifted by. So what we do know is we have a code here. The first word in this code is a day of the week from Monday to Sunday. And we want to find out, after we've converted the string back using the necessary shift, what is the last word in this. So let's get started. I'm going to copy the same functionality that we had from the previous level. Always reuse your functionality. As you can see, we've got this whole thing pointing at our encrypted string. We're applying a shift, and what we get at the end, the shift I'm currently pointing at is pointing at an empty cell. So it's shifting by 0. But what we need to look for here is a day of the week. So let's get these so that we can see them. If we apply different numbers, you can see it starts changing what this says here. And as we go through all the different values, it can be quite tedious to work this out. So what we're going to do is we're going to calculate the shift ourselves. One thing that every day of the week has in common is it ends in the word day. So a very neat trick that we can use here is we can find out what the shift is purely from the last letter of the first word. So we're going to use a text before function to get the first word in here and get the text before the space, the first space. This gives us an ACVLIG. So now we know that the G corresponds to the letter Y for whichever day this might be. So we're going to take the right-hand character of this string to get this letter G, and we're going to get the Unicode character of this. Now, we're interested in the Unicode character of the letter Y as well, because that will tell us how much we're shifted by. And the shift that we're going to get is going to be this number minus the number that we've calculated for this letter. So if we just take that, and I'm going to lock that range, minus this, we now have a shift of 18. And if you see there, the concatenation now starts with the word Sunday. Now there's a second idiosyncrasy coming into play in that what we can actually see here in these numbers is there are numbers and there are spaces, which we didn't have before. Instead of just being characters that are from characters 64 to 90, the letters A to Z, we've also got a space, the number 18. Further down we can see more numbers and more spaces. So what that does is when we're adjusting those characters, say 32, which is not in the range 26, it's then converting this into something that is in the range 26 and returning a letter instead of the space or instead of the numbers. So we're going to add an extra column in here. I'm going to add a little extra check that checks if this is a character. So I'm going to call this column is character, and I'm going to check if the code is in the range of 64 to 90, let's say. So we're going to go is greater than 64, because 64 is the letter below A. And instead of using an AND statement, I always like to think of these as booleans. True or false is a boolean. If you multiply true and false, true becomes 1, false becomes 0. It's the same as multiplying a 1 and a 0 to get the solution of an AND statement. It's the same as adding a true and a false to get the same solution as an OR statement. So I'm going to multiply the two statements to get the condition where the code is greater than 64 and the code is less than or equal to 90. So as you can see, these ones are 1s. We've got a 0 for the space, a 0 for the 1, a 0 for the 8. What we're going to do is we're going to only apply the shift if it is a character. Otherwise there's a shift of 0. We're not going to shift it to the numbers 1 to 29. We're not going to apply the shift to this one either. So this is the shift of adding the 18 that we've calculated from the letter G. Again, if it is a character, apply the shift. Otherwise, no shift. Again, if it is a character, there's probably a faster way than doing this. Let's undo that step, undo that step, undo that step. When we go back to the Unicode characters, we can simply say, if it is a character, use the updated code after doing all these shifts, plus the 64 to get it back. Otherwise, use the original code that it was, because we're not changing those. And then that gives us Sunday, 18th of August is a good day to write a case. For the solution, we only want the last word. So, in the same way we used text before to get the first word, we're going to use text after to get the last word. Text after, however, I'm going to put this just below this so that we can see this. I'm going to call this solution. Text after on this function after a space. But if we just use this as it is, it's going to give us a text after the first time it finds a space. The next condition in the text after function is the instance number. So if you selected instance number 3, it would look for space number 3, which comes after August, and it would just say, is a good day to write a case. However, there's a different number of spaces in each of these arguments, in each of these scripts that we've got. So a really useful function here is to learn that you can actually use the minus to go from the back of the function. So we're going to look for the last space by finding a -1 and use that to simply return the solution case. That gives us the answer to this one. And then we can write all of this out into a nice function. I'm going to just speed up this next bit for you, so you don't have to watch me breaking this all down into one function. Now, we've finally finished levels 1 to 7. Let's run through the bonuses and get ourselves a few extra points. Bonus 1 asks, what is the largest shift in level 3? Shift is just a number that we've been provided with, so this is a straightforward maximum. If we go down to level 3 and select our shift range, excluding the example, this will give us the answer 19. The next one asks you to convert all characters in level 2 to their corresponding Unicodes, and asks for the average of all the Unicodes, including the originally given Unicodes in the level, rounded to the nearest integer. So if we go to level 2, here as you can see we've got some which are already numbers and some which are not. So if we do a Unicode, go if is number, and this is the way I would have done the formula originally, then we're going to take that, otherwise we're going to take the Unicode of that. We're going to copy this down, and from these numbers we're going to calculate the average. So we just take the average of these, and then with that average it's 44444. 4. Yep. 0.55. We want to round this, so we're just going to pop a round around that. That gives us 4445. We'll take this function and take it back up to, let's close Excel Labs, this cell here. That gives us the solution 4445. For our next question, we're asked, which one is the longest message in level 7 based on how many words there are? The way to tell how many words there are in a string is to count the number of spaces. Now this is another great Lambda example that you could potentially set up as a Lambda for competitions. I definitely have one of these, but what we will do is I'll just run you through the slow way of doing this and what would be in your function underlying that. So here are all our encrypted strings. I'm going to take a copy of these and just pop them into our sheet 1 where we've been messing about a little bit. These are our strings. The way to check how many spaces there are, and there will be however many spaces there are, is the number of words minus 1. So first we get the length of this entire string. Then we substitute any spaces out of the string and replace them with blank. Quote, quote. No values. This gives us all the words concatenated down without any spaces in. And when you take the length of this, I'll just move these across a couple of columns. When we take the length of this, it will be a little bit shorter than it was previously. And the difference between these +1 is the number of words that you have. So the difference between them is the number of spaces you have. We've added 1 to get the number of words. And what we're looking for in this bonus question is the number of questions, the number of words. So we're going to just get the maximum, the number of words in the longest one. We're going to get the maximum of this, and that returns the number 12. For the fourth bonus question, it asks us in the messages worksheet, how many times does the most frequent Excel crime occur? Now, we haven't looked at this worksheet yet at all. So what we do have here is a data table. It's not actually a table, but we've got this list of all of these things, which are functions or Excel crimes. And we want to know which Excel crime occurs most frequently. I'm going to convert this into a table. So just select the entire range, Control T lets you make it into a nice little table. We're going to call it messages is fine. And what we're going to do is we're going to actually filter this data using a filter function. So if we filter, first up, we're going to filter the topic, the message topic. So messages is our table, open square brackets to get the column header that you're looking for, and there is message topic. Close square brackets to close up that lookup. And then the second argument of the filter is a condition. So it's not just a column, it's what that column should be. So we're going to treat this as a Boolean. First, we're going to look up the column, messages, and we're going to look up Excel crime. Now, Excel crime is currently a yes or no value. We don't want it to be just a yes or no value. We want to have a condition in this spot. So we're going to check it against the string yes. So we're going to say Excel crime equals yes, because we want just the crimes. This gives us a long list of all the times that someone has committed an Excel crime in this sheet. So we don't want a massively long list, so we're going to generate a unique of this list. The unique function will return a list of all the items we have in our full list, but only shows them once each. Now we have a list of all the Excel crimes. We want to count how many times each of those occurs. So we're just going to do a straightforward countif on the range messages, message topic. And we're going to check how many times each of these crimes has occurred. There we've got a total count for those. And for the bonus, we're looking for the maximum of these. So how many times does the most frequent Excel crime occur? So again, we're using a maximum. This is quite common in bonuses. We select the range that we've got, and that has returned the number 15. On our final bonus, we're again looking at the encrypted strings in level 7. And we want to know how many times does the most used letter appear. So a nice simple way to do this, we've already got these in our sheet 1 here. So we have that function that we wrote earlier to extract all the characters into an array. We'll go and copy that from level 6 or 7, wherever we've last used it. Going to copy that one, which if you've done what I suggested, you now have a lambda for. We're going to put this in here, and we're just going to change this to point at H3 because I don't want this to go down the way. I'm going to wrap that into a transpose function so it goes across the way. So at the start we go transpose, open brackets, the end, close brackets, and now we have all of the letters there. So now I'm going to copy this down just so that we have all of the arrays. And as you can see, if we go up to the top, it's not the longest array. The longest array is actually that one. So for the sake of this, I'm actually just going to select this entire range here up until column BK. This is the range we want to search for each of the letters in the alphabet. So I'm going to give this a name just to make it easier to search. Let's call this search in. Now we need a list of the letters of the alphabet. As we saw earlier, you can do a sequence of the letters from 1 to 26. I am just taking this as unit character of our sequence 1 to 26. Plus 64, and that should give us the letters A to Z. Now we can just do a countif on the search in range that I've just pointed at for each of these letters, and that tells us how many times each letter appears in these strings. This is looking for how many times the most used letter appears. So again, we're using a max function, and we're going to this array that we've set up here. And we hit enter. That gives us the number 37. And there we have the solution to bonuses 1 to 5. That completes our walkthrough. Thanks for watching today. I've been Jack. Come and find me at XLtism or XLtism Jack for some more content and to find out more about the UK XL World Championship.